Which questions?
Definitely doing 6, 7, and 8.
Which questions did you get right?
All 1.
Hey, Malcolm,
Which one?
on number 5, what
And
is
I got
your
2
answer?
almost
Because
right.
mine just says and.
Number 5?
Yeah.
Okay.
Number 5. Oh, I got number 5.
Oh yeah,
Okay.
I'm surprised I got number 5.
What questions do you have from the test? And no, we're not going to do as many as whatever you just came out of your mouth, so choose wisely.
4.
4 sounds fine.
That sounds fine to me.
You didn't put the X there after right there. You didn't put that there.
And then 6 and
I didn't put the, I didn't put the X minus
4,
Yeah.
6.
Yeah, I'll even do 4 twice.
What?
Because there's a way to do it where you don't even have to use anything from this unit at all.
Could we do 4, 6, 7, 9? Just those 4?
We can do number 4 right now. That's what we're doing currently. And we will see from that. So number 4, we had x cubed minus 2x squared minus 3x plus 6 equals 0. And we are asked to state the number of complex roots, the possible number of real and imaginary roots, the possible number of positive, real, negative roots, and possible rational roots for the equation, then find all the roots. So what could we do?
Find all the possible positive real.
Yeah. And mod 6.
Possible real or rational?
Real. Wait, rational. Wait.
Possible rational ones.
Whatever that thing is that you divide the last thing by. You always get things off.
Okay, so what are those?
2 and 3, and then 6 and 1. 2 or 0.
Oh, wait. That's...
Right? Factors of 6 over the factors of 1. Great, done. Now what?
Now count the changes in size.
Changes, sounds good. So positive real ones. There's 1, 2 changes. So there could be 2 or there could be 0. For the f of negative x, we've got negative x cubed minus 2x squared plus 3x plus 6. So 1 change. So there's 1 or 1.
And there's either 2 or...
So if there's 2 and there's 1, then there are no complex. If there is 0 and there's 1, then there's 2 complex. Sounds great. Sounds very good. So what now?
I messed up on something.
Do what?
I went in out of 4 instead of out of 3.
Try to
So I
find
messed up my table.
Yeah, we'll try to find something.
2.
2 sounds great. Let's do it.
I think Malcolm's cheating. I think he's played these games before.
Yeah, I have. Because I did the test.
Well, you could have looked at the picture and whatever and figured out it's probably true and then tried to, right?
Yeah. I tried.
So bring down the 1 and then 2 and then 0 and then 2 times 0 is 0 and then negative 3 and negative 6 and Bob's your uncle. It works. Now what?
Now we put that into the thing and see if we can back it.
Yeah, so that's right. So we've got x minus 2 times x squared minus 3 equals 0. We don't have to see if we can factor it. We can solve that without factoring at all. How can we solve this without even factoring? Just add 3 to both sides. We've got x squared equals 3. So take the square root of both sides, and x equals plus or minus the square root of 3. X equals 2. Are we supposed to write? Didn't ask to write the factored form, right? Just asked to find the zeros?
Yes.
Right. So there it is. So that's great. That's grand. That's glorious. And we're finished, right? That's how you would expect to solve it with this one. We could also solve it a different way.
Wait, what were we supposed to find then?
There's 1, 2, and 3 roots. There they are.
Plus or minus.
And find all roots.
Plus or
Yeah.
minus square root.
Oh,
we
yeah,
did.
we did. Yeah, I was thinking just
Wrong.
incorrect.
We could also jump over here. We could factor an x squared out of the first chunk and leave us with x minus 2, and pull a -3 out of the next chunk and left with x minus 2. Pull an x minus 2 out, leave us with x squared minus 3 equals 0. We could just factor it by grouping. And then we end up here. That's also a way we could have solved this one.
Hold on. Let me
Well,
look at that more intently. So
Let me look at this more intently. He's a studious boy.
These people are crazy. But you knew that if you've joined this class before. Where is my coffee mug?
All of the study guide. It was awesome.
Okay. What other questions from the test do we have?
I said other ones. I don't remember.
Everything
the word.
else, I just
You
messed
did
up
say
in
six.
minor ways.
Let's do 6. Either 5 or 6, but I got 6 wrong more, so let's do 6. He's got 6.
Okay.
6 was more wrong.
Use the factor theorem to determine the binomials are given factors. Use the binomials that are factors to write the factors for. Great. Easy peasy.
What happened here?
I just got a bunch of synthetic.
He did synthetic division. I got.
So technically yours was the most correct, but I didn't need all of that. But
Yeah.
technically, yeah. Yeah, yours was, everything you were thinking was right.
I just forgot to add the extra little thing in it.
Why are you taking my stuff? I don't care. Sean is the only one that can draw.
You do that smiley face.
No, Sean did when I went out of the bathroom. Remember?
Oh, I do remember that. That's funny. Oh, wait, no.
Not like you did, but then.
All right, Landon, what should we do?
I did my
We should do like.
That's a good question, Landon.
My pencil's now over that. I forgot. I completely forgot the factors here, so that's what my whole issue was. With this problem.
What do you think we should do?
What would I do here? I would put the x plus 4 in the cardboard box, and I would start.
Yeah, so you would divide it. And the factor theorem says that if it comes out with a remainder of 0, it is in fact a factor. So yeah, you would do that. Did you do that?
He did.
What did I do?
Did you do positive?
Yeah, but I
Did you change it to a -4?
No, I did the division very wrong.
He did the long
Okay.
division.
Okay.
Yeah, but then I also didn't.
8,
I did, and I didn't.
32,
Yeah, I was so confused.
3, 2, 5, 20. You got to not forget to add the zeros that are in there, right?
That's where I was messing up at first on problem number 3, and I couldn't get it right.
I
And
almost
redid it
messed.
like
I
4
almost
times
messed up.
because I left off
8,
0 that entire, and I left off 1.
32,
And I left off 2.
0, 0, 0, 0, 0, 0, 5. And then -20. So yes is the first bit because that. So what would the depreciated equation be?
8x to the 4th plus 5. Plus 5.
And see, this is where I.
Yeah, I just did the division.
You could also keep going
And distributed.
and get, no, that would go back to that.
Oh, yeah.
You could also keep going and do some like quadratic formula type shenanigans and end up with an even more factored version. This is good enough.
What? Is that what Malcolm did?
Yes.
Yes.
Yeah, you certainly could do that.
I didn't do it the second time.
What else?
Can we do 8 and then 9, and then that's all I need. Because that'll give me one of every type.
We can do 8, and then we can do 8. And then we can move on to the next thing.
We can't do a graph?
Now,
Oh.
you have notes. You have lesson stuffs. You'll be fine.
Well, I didn't actually miss.
I actually didn't get 9 very wrong.
I missed stuff on 9, but it wasn't because I actually missed it. It's because I didn't.
You want to do 8, not 7. Is that what you're telling?
More wrong. Yeah, actually, let's do 7 because it looks harder.
Because
I don't know how I
You got
got 7.
minus 12 on.
they are both easy. You probably just made a careless mistake, but we will at least start it. So how would we start on?
I did study, but then I forgot everything.
We start
How would we start number 8?
x minus 2, x plus 2, x minus square root of 2, x plus square root.
I said number 8.
Oh, 8. X plus 4, x minus 2, x minus 4.
So we start with, yeah, f of x equals x plus 4 times x minus 2 times x minus 5. I'm going to give, this is not the first time I've given you this advice, everyone. It is good advice. It is really good advice, and it will make studying so much easier. You should start studying for the Unit 3 test today. Because see, here's the thing. If you study a little bit on lesson 1 today, and then a little bit tomorrow, and then a little bit the next day, then by the end you get to the practice test and you're studying the thing, it's a breeze. It takes half a second. It's easy money. It'll make your life so much easier. Make yourself a little check box. Say, did I do this thing? Did I spend 15 minutes doing this? Yes, every day, on these days. Then I can do whatever I do for fun. Play a Clash of Leagues on my phone, or golf, or whatever the heck I do for fun.
He just named my 2 hobbies: Clash Royale,
Clash of
golf.
Leagues and go play golf.
Clash of Leagues and golf.
All I'm saying is I promise you that if you will do that, not only will you do better on the test, but your stress level around the test will just plummet to like nothing.
It wasn't like that in the first place.
Yes, it was.
What?
Yes,
It
it
was a
was.
joke. I was saying, it wasn't like that in the first place, Sean.
Bad
Oh,
joke.
great. Yeah, because you're so smart. Okay. And then you just distribute. X times x is x squared. X times negative 2 is negative 2x. 4 times x is plus 4x. 4 times that is negative 8. And then you do that again. And then combine like terms. And then Bob's your uncle. And then you're done. As long as you don't forget to write an X.
This is so easy.
I know it's so
How
easy.
did I completely forget everything about this fucking problem?
I'm surprised we didn't do any imaginary.
And I studied for like 4 hours.
The square roots replaced that.
We had square root of 2's in the last problem and stuff.
Yeah. Yep, that's exactly right.
My mom finally realized that math is hard, so now I don't get like murdered every time. I look at it.
Well, you are in pre-cal, so
My mom finally realized that math.
when single lessons are basically the same amount of content as entire chapters of Algebra 2, yeah, there's a lot. There's a lot.
She never thought math was hard. She was like, "You're good at math. It'll be fine. Just study a lot." I'm like,
I'm dying.
and then I just get grounded. I got grounded a lot last week. Okay. Yeah. I mean, a lot. It didn't matter though because I didn't have cars. What was I
Okay.
doing? I was at Fortnite. Now I
Let's
realize-
do today's work, shall we?
I realize that now.
It's the worst thing ever.
I don't think I've ever played Fortnite, but I can't imagine it's the worst thing ever.
It's not.
I also think that it is, from watching it, it is the most ADHD video game I've ever seen in my life. It's nuts. So,
I do have ADHD.
all right.
So yes, it does work for me.
Exponential functions is what we're starting today.
Really?
Yes.
Exponential one.
This chapter is on exponential and logarithmic functions. It is
Done this. I played these games.
all review. I want to hold off on saying that sentence for half a second.
I'm not playing now, but
Yeah, it is quite literally all review except one little thing tacked on at the end, which you do with your calculator anyway. So we will be going relatively quickly. All that said. So exponential functions have two parents. They live in a two-parent household, unlike parabolas and a bunch of other stuff. They have exponential growth and exponential decay. Exponential growth parent function looks like this. It goes through, the parent function goes through the point 0, 1. The limit as x approaches negative infinity is 0 for its end behavior. The limit as f of x approaches, as x approaches negative infinity of f of x is 0 on that end behavior. The limit as x approaches positive infinity of f of x is infinity. That's the growth function. Looks like that. The equation looks like f of x excuse me, equals a b to the x minus, this is actually the transformation, not the parent function, but all the things, plus k.
So what would that look like in numbers?
Well, those a, h, and k and whatever could have numbers in them.
Yeah.
The transformation works exactly the same as all the other stuff, parabolas and all the other stuff. If a changes, it is a vertical dilation, a vertical stretch, or a vertical compress. It works like you'd expect. B is a horizontal stretch or horizontal compression. It works the opposite of how you'd expect. If it's a big positive number, or here it's going to compress horizontally. If it's a little bitty fraction, it's going to stretch horizontally, which is the opposite of what you expect. A works exactly like you expect. If it's a 3, it's going to vertically stretch. If it's a 1/2, it's going to vertically compress. Right? H, horizontal translation, works the opposite of you'd expect. Horizontal works opposite, inside opposite, right? All right, horizontal, if this is a +3, it moves it to the left. If this is a -4, it moves it to the right. If it's on the outside and it's a K, it moves it up and down. It's vertical translation. That moves how you'd expect. If it's +15, it moves up. If it's -12, it moves down. Okay? Vertical decay, exponential decay looks like this. I don't know if you figured this out or not, but we're probably going to cover 2 lessons today. Which means you have 2 homework sets again.
I should have asked more questions.
You tried, but he didn't.
Yeah, I should have asked more questions. I felt bad, sorry. You should have asked the question, but probably you missed them. The k parent function also goes through 0, 1.
The equation is the same. We'll do a couple examples showing and when the equation looks like one and when it looks like the other. And it looks like this.
So it's just the reverse.
The limit as x approaches negative infinity of f of x is infinity. And the limit as x approaches positive infinity of f of x is 0. No, it's not the opposite. That's the
Inverse.
the logarithm. Logarithmic parent functions are the inverse of the exponential parent functions. Yes, yes, they are.
So they're flipped. It would be more
flipped over this.
What is that called?
Inverse. You're right to begin with. Y equals x. Linear parent function. I don't know. What are you saying? Nobody knows.
Where it's not translated, but reflected. So it's reflected over the y-axis.
Yes. No.
No?
This is. Yes.
That's what I'm talking about.
Oh, okay. Yeah. Yes. It's a reflection over the y-axis.
Negative x minus h, like would be decay and then positive.
What are you saying?
He's saying if
Like
x
when
was
x is-
negative versus positive, would it be growth?
Well, let's do some examples to remind us what it is. See whether you're right in your remembering guesses or not.
This guy. Yeah, what about this guy?
So, without using a graphing calculator, let's graph a couple things.
Okay, I'll grab my calculator.
Let me grab my calculator real quick.
You would get hurt.
Is that anything I need to care about? Probably not, since they hung up. Molinos and a hawk. No, not Havana.
Why did you start
Who is this person?
Did you see that
I did.
text I sent to the
I think I should be able to go in about 7 minutes. So I'll just respond. Dave Ramsey stuff.
off-brand Dave Ramsey?
No, Dave Ramsey's he's an assistant.
We don't even get the real one?
Well, because that guy graduated from LCU.
We get the off-brand Dave Ramsey?
Because I think that guy went to LCU.
What about on-brand? I don't want the off-brand Dave Ramsey.
He wants the on brand.
No, I don't want the on-brand Dave Ramsey, really.
You don't want either?
No.
You want no?
Why did I just write the A as an @ sign? It's fine.
Because you're like, there is no H. There is no H. But there is a K. Oh, right.
All right. Let's do some examples. These are the examples. And then we're going to talk about a few specific exponential growth functions that have to do with money. So, yay. Well, also rabbits.
Rabbits.
Yeah.
Why was rabbits? That was so sick though. Rabbits. I've
Okay.
just accepted it at this point, I guess.
All right. So, if we're going to graph this, what is it going to look like?
It's gonna look be like slightly vertically dilated in a good way, not in a good, in a positive way. Slightly horizontally dilated in a negatively way, and it'll be
It's gonna
translated
shift
vertically
it up one
slightly.
space and like.
Let's pick a few points and see whether you're right. Put your calculator down.
My calculator, what is it?
It went up.
The
None of
numbers
us
are
are
up.
calculator up.
Great. Is it going to go through 0, 1 still? First
No.
question.
No.
No.
It's gonna go through.
It's vertically
0, 2.
translated.
Going to 0, 2.
In a good way.
So let's confirm that. We put a 0 in here. 5 to the 0 is.
5 to the 0, 0.
I was hoping you would say that lie, but no, it's not 0. It is 1 times 2 is
2
1 times 2 is 2.
plus 1 is.
3.
Oh, look how wrong you are.
We're doing A to the point of 0.
So where does it go through?
It goes through at 3.
It goes through at 3.
How? It was translated 1.
Crazy.
What? I do believe it is.
That's what I said.
Great.
And I agree. Like,
So what
big deal.
points do we want to plug in here?
We want to plug in like
0.
we're in here.
It didn't shift left or right any, right? So Like, we can do all our old standbys, right? 1, 2. We already know that this one is 3.
We should also do 7.
No.
And 6.
We don't want it to. No, not. I didn't mean that as a real.
All right, if I put a -2 in there, 5 to the -2, stop that. 5 to the -2
Is 1/25. 1/25.
1/25.
Times 2.
2 is 2/25. So 1 and 2/25.
Wait, plus 1. Oh, yeah.
Plus 1. It's already there. And -1.
-1 in there is 1/5 times 2 is 2/5.
Plus 1 is
A little bit bigger than that.
1 and 2/5. Plug a 1 in there. 2 times 5 is 10. Plus 1 is 11.
Oh, never mind. 7 would have been off the board.
11, 28. I just did that whole thing. What?
5 times 5 is 25 times 2
50.
is 50. Plus 1. 51.
Why am I adding 2 to that? I added 2 to that and then I added 1. I'm like, what? Losing my mind. I actually wake up.
What is the limit as x approaches negative infinity?
Let me look at it.
You got it.
Negative 0, 125, 0.
Definitely not 0.
Wait, negative infinity?
1. What are we trying to?
It's 1.
Yeah.
I just asked a question.
I couldn't hear you overhand.
Great. Everybody else hush and let me ask it again. What is the limit as x approaches negative infinity? 1. Definitely 1. The bigger this gets, the closer to 1 we're going to get, but we're never going to get anywhere past 1. So we moved up the asymptote here. We do have an asymptote. Just 1. No. And then very quickly he heads that way. Right?
I didn't write any of that down. It's fine.
Oh, wait.
I basically read it. It's very simple. You just graph it.
If the instructions said graph and this was all it asked for, this would be enough.
Okay.
Just the graph would be enough.
Well, that's
This
exactly-
would be enough. Yes.
That's exactly what
Now it's probably going to ask you for the domain and all of those kind of things. It might ask you for critical points. If it asked me for critical points, that would be intercepts, right? Intercepts and asymptotes.
0, 3, and then positive 1.
Yeah.
graph it and then look for the things.
Let's do this one.
So this one's probably going to be the how do we know the difference?
We don't.
Exactly.
Yeah, I remember it now. I'm pretty sure. When it was when b is greater than 0 and less than.
What? Greater. So if b is a fraction, it's decay.
Well, they're all fractions, but if it's greater than 0 and less than 1.
What you think of as a fraction in
Ah.
third grade?
I'm in the middle of
So what
argument, conversation.
what happens to this guy?
He
He
got
goes
squished and expanded
and moved.
and shifted down.
No,
No.
it's not.
Shifted
To the left.
to the right.
Wait, no,
To
it's
the right.
It's stupid. To the right. So it'll be
One of those things was a lie, and it's a lie because I told you a lie and I did it on purpose. But it's okay, because we're already y'all are in your argument. You're already starting to puzzle out the truth, or one of you is anyway. Okay. So what points should we use? Because we shouldn't use these. That don't make no sense because we moved over.
negative 100.
Why?
We should use like 1 and 2 and 3.
And 6 and
No.
Well, our middle point should now be 2, right?
Yeah, because we moved to the right twice. But we should also want 3 and 4.
Yeah, easy money. We may need more than that. Probably not. These are simple. These are much simpler graphs than last unit, right?
Yes.
So that's probably enough. We plug a 0 in there.
Negative
0
third to the negative 2.
minus 2 is negative 2. What is 1/3 to the negative 2?
Negative 1/6. Wait, square.
No, is it 3 squared? Or is it?
It is 3 squared, which is 9, times a half,
4.5.
4.5.
I couldn't remember if it was 1/1/3 or.
That's the same. Yeah, you'd have to kill that compound fraction, and it'd be a 3. Yeah, same.
So yeah.
Yeah. Great. We put a 1 in there. 3 to the 1/3 to the negative 1 is just 3. So 1/2. Water's gonna be 1 and 1/2. Right?
Yep.
Yeah.
Put a 2 in there. That's a 0. So 1/3 to the 0 is 1. So 1/2. Right?
3 minus 2 is 1.
1.
1/3 to the 1 is 1/3.
1/3 times 1/2 is 1/6.
This isn't a decay.
4 minus 2 1/3 squared is 1/6, I think. Am I retarded?
Wait, 4 is 2.
Ninth, 1/9, not times.
Oh,
So
yeah,
one,
it's
yeah,
three-
yeah,
three-
3 squared.
3
Yeah.
times 3 is
You were thinking right. You just like your brain made the mistake. You were on the right track. You knew what you were doing.
1/9 times 1/2 is 1/18.
1/18. It is true. What is the limit as x approaches positive infinity?
0.
0. Asymptote is still where it is.
1/18. No,
0 and 4/2. 4.5. 1, 2, 3, 4,
It looks so funny.
and 1/2.
The last one.
So right there.
It's sitting like this.
And then 1, 1.5 is right there. 2, 1/2 is right there. 3, 1. Now we're just getting closer.
So it's not a dude. No, it is. What am I thinking?
You're thinking the wrong thing.
I was thinking wrong.
So it is, in fact, exponential decay. So where was the lie?
Say that in the
So where was the lie?
Where was the lie? What
Oh, I thought you said.
I will tell you when was the lie, and you got to tell me where was the lie.
This feels like a game show. When and where was the lie?
So
Sounds like a dumb game show.
To the right, we did do that, but it doesn't appear that we.
Doesn't look like that.
I think it's the B.
It's the B.
It's the B.
The B doesn't have anything to do with horizontal vertical compression. Has to do with whether it's growth or decay. Now, we could make a horizontal compression by modifying our function to something like this. Times, I don't know, B times C to the x minus h plus k. Something. Then it would be horizontal compression here if we had another variable inside here, inside the parentheses. Right?
What if B is negative?
Oh, what if B is negative? Now, that would be changing this letter, the B instead of the C.
So
It would
where
be.
does B become negative?
So your intuition was not wrong, or you're remembering one of the two. When is it growth and when is it decay?
When B is greater than 0 and less than 1.
When B is greater than 1, it's growth.
When B is less
When
than 1.
when B is between 0 and 1, it's decay.
So what if when B is below 0?
When it's negative. What if A is negative or what if B is negative? When A is negative, what would happen?
It would just flip.
It would be a vertical reflection, right? What if B is negative?
It's not going to be a horizontal reflection.
It is going to be a horizontal reflection. Let's do one just to prove the point.
Between 1 and 0, but it was negative 1. It
Yes.
would be growth, but if it was between.
No, you're saying that wrong, but
No, between negative 1 and 0, it would be growth. Would it not? Because it would be decay.
no,
so
it would be decay, but it'd be reflected.
Yeah. So isn't that just growth?
So, yeah, when you start getting into some, yeah. So, yes, you wouldn't model it that way. You would model it as growth. You would because as you got to think about these as I know we're doing these abstracted from real life, But what is this for? This is for situations that are actually modeled with exponential growth and decay, like compound interest, like half-life of radioactive material, like rabbit populations, like all of these things. You know, there's lots of real-life situations for at least part of their real-world domain that can be modeled with exponential function. Okay, so here are some formulas that you need to memorize. You have seen these before, but these are ones that you just need to memorize. Okay? Compound interest formula looks like this. I don't know that I actually need the book, but looks like this. A equals P times 1 over R over N, excuse me, 1 plus R over N to the NT. I don't know why I even know the book. I know that one.
So is that in both in there twice?
It is in there twice. What does A stand for?
Answer.
No. It is the amount after T years. What is P?
Prerequisite.
It is the principal.
Principal investment.
Yes.
Yes? Oh. It's the amount you actually put in.
Amount that you put in at the beginning. That's true. I cannot. We're not even going to do an example using these. I'm just going to give you the formulas and we're going to move on. This is review upon review. But I cannot hit this formula without stressing to you that the most important variable in this equation is the t. The t is the most important variable, and what I mean is the sooner you start investing for retirement or your car or your whatever, the better you're going to be. If you are still a minor, which I think most of you are,
He's a minor.
there may be other investment companies that have the same thing, but I know for sure that Fidelity has a great youth investment program that you do under your parents or whatever. You can start investing as early as 16. So I would look into it. I would hit up your parents and start talking about it. It is a good idea.
Are you 17 yet? I already have an investment. You're not a minor anymore.
You're still a minor. So.
What is the N stand for?
You're not a minor at age 17.
You're just not that.
Other than marketing.
Yeah. You're like.
Because N is what I call the marketing variable. N is the variable that it matters but not enough to care about, and this is the variable that banks and other people will be like, oh, they're compounded blankety blank blank, and they're like, oh, it's so awesome. It does matter. It just doesn't matter as much as they're going to try to tell you. N is the number of times it is compounded annually. So if it's compounded quarterly, N would be 4. If it's compounded semi-annually, it'd be 2. Daily, it'd be 365, et cetera, et cetera.
Daily. I want daily.
It doesn't change it as much as you think. Like do a few computations. You can even build you a quick spreadsheet or whatever, and then run it out. It affects it, but compounded daily doesn't give you as much as more as you think. The T is much more important.
If you have extra T with compounded daily, would it not be excessively large?
Because of the division, it doesn't make as much a difference as you think, because it takes your interest rate and it divides it by 365.
Oh.
So.
What if it was the same interest rate with daily? 5%.
No, that's a totally different formula.
We just blow that up.
That you'd have to do a little bit of math. That's not a thing. Okay. So R, as you guessed, is the interest rate. It's going to pretty much always be a decimal, right?
Give me 2 times.
12% interest rate was the 112.
And then T is time.
T is time in years. That is true. That is true. At 6 months, it's 1/2. Okay.
Wait, rate, so yeah, rate is just interest.
Other formula that you need, so we can have compounded annually, daily, weekly, all of those things, yearly be one, right? All of that stuff. What if it's compounded continuously? Then the formula is a little bit different. So this is for compounded continuously. The formula looks like this. Same variables. E is not a variable. Words. Sometimes they're hard. E, do they have the spelling for me so I don't misspell this word? They probably don't. Let's see.
Euler's number.
It is Euler's number, and I'm going to make a stab at spelling it because it doesn't tell me.
Wait, what is that?
What is Euler's number doing there?
Oh, I remember.
I think that's how you spell it, but I could be lying.
That's what
That's at least close to how you spell Euler's number. It is words. It is a number like pi is a number. It is.
Why do they keep finding these stupid numbers?
Isn't it like
So it's not a stupid number, just like pi is not a stupid number. Pi is a number that God made and made how circles work, right? And Euler's number is a number like pi that is derived formulaically. It is a what is the word I'm trying to say? My brains keep trying to say improper. Irrational number, not imaginary. It is an irrational number like pi, and it is calculated using a logarithmic series. You can look up how it's calculated. We don't really care. It's 2.718, whatever. Right? You do have an E button. So when it's compounded continuously, you use this formula. Right?
What's the general gist of the number like?
2.7 something.
For 2.718. I just said you can literally just punch it in the calculator. Yeah.
2.7.
Isn't there like Euler's identity, which is like
Euler's identity is a thing. Yes.
What's the fancy name for half of pi?
It's not half of pi, but double pi is tau.
Tau pi. Okay, because that's what I was thinking.
And tau is the better circle constant. That is definitely true. It makes like all the formulas better. In fact, it's so almost better that a dude wrote an entire book on it called the Tau Manifesto. What's her face? Vihart has a great video about it.
You know what that sounds like? The Tau Manifesto? Sounds like some kind of crazy person was right before like communists would right before like bomb the Capitol.
No, because the Communist Manifesto is a thing.
What?
They would write that instead. The Tau Manifesto. Manifesto?
I think y'all don't understand what the word manifesto means.
Yeah, I don't. I'm not already did.
Fancy word
I'm not
about
pretending I do.
rebellion and murder.
Remember what he did?
Yes, I do.
That was such a great class. I love
Okay,
that word.
there's your first homework set. Let's do another one.
Oh, right. Write that down.
Logarithmic functions, aka inverse exponentials.
Homework. 2:24.
So remind you what a logarithm is. So the logarithmic form would look like this. Logarithm is just the inverse of exponents. I mean, that's really that's really that's a T.
Logarithmic functions. I don't want to.
This unit, by the way, I don't know if you've noticed, or like this unit really is review. This unit is going to go very quickly. We're going to have another test, and then we're going to get to trig. That's how this is going to go. So hold on to your butts. Soon, like way sooner than you think, because there are 6 lessons, and we're going to get through 2 of them today. So you probably have a test next week.
Next Thursday.
Quite plausibly. The following Tuesday at the latest. Okay. Logarithmic form looks like this. The log base b of x equals y. Now, to convert that to exponential form, it's the base b to the y equals x. So the exponential form focuses on the result of the power, right? That's what the highlight is on. The logarithmic form focuses on the exponent. So logarithmic functions are they're a model for real life data. Sometimes they say it's logarithmic is very useful. A logarithmic scale is exceptionally useful. You should watch out for that when somebody's sending you some sort of political graph or whatever graph. If it's in logarithmic scale, it can take something that looks like and turn it into which this is much scarier than right? So, or the other way around, right? So logarithmic scale is something to pay attention to. Logarithms are also a tool to help us solve for exponents. Sometimes things in math are ideas and concepts like specific functions and whatever else, and those are used to model specific data. And sometimes they're a stepping stone tool that mathematicians came up with to help them solve bigger problems and more complex problems, right? That's the idea. So logarithmic parent functions, properties of logarithms. I guess we'll write all of those. I don't want to waste our time, but that's fine. So here's a few properties of logarithms that are intuitively obvious if you think about exponents, and you've seen this before. Again, this is all literally all review. Log base b of 1. So what exponent makes everything 1? 0. So log base whatever of 1 is 0. Log base b of, oh, just kidding. This is not log base b. Where am I? Oh, I know I'm looking in the wrong place. Of b, so if I have something and I raise it to something else and it stays the same, what does it equal? 1. Something to the first, is that something? If the base and the argument match, the answer is 1. Easy peasy. All right. Oh, I thought that said something else. I was like, wait, what? What are we saying? Log base b of b to the x. So log base b of b is what? 1. And another property says, and we'll write this, that if we have argument to an exponent, we can take and we can pull this exponent out to the front. X times 1 is x times 1 is x. Thank you. So log base b of b to the x is just x. And if we have b to the log base b of x, what would that equal?
B would be b to the x.
It would equal x.
Or sorry, x. Oh, wait a minute. Oh yeah, because this is putting log.
This only works if x is greater than 0, not if it's less than.
So the bottom, that one we just did, is the same as the one above it?
Yeah, the result is the same.
Okay.
Huh.
We could write a proof for it, but we're going to keep moving.
No,
We're not.
So
we
how
don't
do we
mention-
take log from multiplying times b to being to the exponent of b?
What are you saying?
So how do we transfer log from being here by b to being above in the x position?
We didn't do, this is just a, this is just a, oh.
Is there a way to change it from its positioning?
We'd have to convert this whole thing to logarithmic form. Okay, so if I just have log Base nothing. There's nothing sitting there. What's the base?
1.
It's not 1, but it is 10.
I just guessed. It's usually 1.
If we just write log without a base, it's log base 10.
Why is it base 10? Because people like the number 2.
Because we're that's a great question. It's because we use the decimal system. Our math is based on base 10.
Huh. Okay.
So the generic one is in 10.
Okay.
All the same, I'm not even going to rewrite these, but all the same things would apply to log base 10. So log of 1 is 0. Log of 10 is 1. Log of 10 to the x is x. Right? Okay. Other fancy schmancy base. This, by the way, has a name. I didn't write this a minute ago. This is the common log. This is the natural log. That is true.
Like a redwood log or something? I remember eating birch log.
And it is the log base e of x.
I do not understand this very well.
It's just a number, like pi.
No, I know. It's just hard to understand. Whenever it's irrational, you're just putting it in an equation.
You got this.
Log base e of x.
All the same properties apply. With here, if we have the natural log of 1, it's 0. The natural log of e is 1. The natural log of e to the x is x. Also, the derivative of e to the x is e to the x, which is great. But you won't learn that unless you go learn calculus.
We're learning pre-calculus.
Yeah, which is not basically calculus. Okay.
Basically pre-algebraic calculus.
It's basic. Pre-calculus is basically pre-calculus. Imagine that. Who'd have thunk it? Okay. What about graphing the things? They also have a growth and decay. We're doing great. We're gonna smash right where we need to smash. Yep. Smash or pass? Smash.
What are we talking about?
Math.
Yeah, you gotta have that in contacts.
Yeah, have it in contacts. That's right.
Have it in contacts. Just don't know the number.
Exponential, no, logarithmic growth function. He is the inverse of the exponential growth function. Surprise, surprise. Instead of going through 0, 1, he goes through 1, 0. Right? Easy peasy.
He's fake.
No, he's not fake. You're fake. He goes through there, and he looks like this. He's got a vertical asymptote at x equals 0. And he looks like that. The letters look like f of x equals a times the log base b of x minus h plus k.
Oh, so it's the same except for the log.
That's true. Imagine that. It's almost like they're related.
Wait, is h and x in an x?
These are like the aunt and uncle.
Is h and x in what's it
Yes.
called? Superscript or right?
No, not this. There's no superscript. X minus h is the argument of the logarithm.
Okay.
Kind of how parabola flips when you square root. Like maybe square root when you flip inverse of the parabola.
Yeah.
When it goes from here to here.
Exponential decay still goes through 1, 0. Not what you expected. It also still has a vertical asymptote at x equals 0. And he looks like this.
I guess it does make sense.
And that's it.
How do we write
You graph them the same way. What?
Do we write this one in except x?
When do you think it's growth? How do you know if it's growth?
Would it be b or x though?
B.
B.
X, remember, is going to be the variable. That is the independent variable.
Okay.
When b is greater than 1, it's going to be exponential logarithmic growth. When b is between 0 and 1, it's logarithmic decay.
And then when it's negative.
Horizontal reflection. When b is negative.
So basically, when B is negative, do the opposite.
It's a reflection. Horizontal.
Where it says, do your homework, go home, kids.
Find someone who loves you, give them a hug.
Yeah. She says that some too.
We should do 2 through 4.
Page 148. 2 through 4 odds.
Okay, that's only 3,
so
yes,
much.
sir.
Wait,
how
how
are
are
they?
Oh, 3 doesn't look too bad.
2
4
through.
odds. 40.
Oh my
40.
God.
That's probably not that bad.
Okay, goodbye.
It's either easy or it is going to take us hours upon hours.
I bet it's in between. Do we have any comments?
Nope.
Questions, comments, concerns, fits of rage? No comments.
Nope, no comments.
They hate us.
Only 3 views and nobody sticking around.